Okay, so just a few things on common acids and bases. Some of them are important to know, especially in your high school work. Otherwise, you will normally work with these acids and bases in the laboratory. Okay, so when you write the formula for a particular acid, it's always important to know what is the cation and the anion that is involved in the acid. So, and normally you will see that acids contain hydronium ions or protons, which is just a hydrogen ion. And then for the sulfuric acid, it also contains a sulfate. So these polyatomic ions are very important, and you need to go study them. So when you compose your formula, you need to then make sure that this number that you have over there, you write on that side, and this number here, which is just a 1, will then go on that side. But remember, this is a polyatomic ion, so you're going to keep that in brackets. So when you write your final formula, it's just going to be H2, because that 2 went over there, SO4. And that's going to be the formula for sulfuric acid. The common name it's also known as battery acid. And normally sulfuric acid is mainly used in the chemical industry, especially also with the production of fertilizers and dyes and other synthetic detergents. Then hydrochloric acid, commonly also known as pool acid, or basically also stomach acid. I think your stomach acid has a pH of 4, so it's quite acidic. Then for hydrochloric acid, the formula is just HCl. Okay, why? Because hydrogen is +1, and the chloride is in group 7 in the periodic table, which has a charge of -1. So when you write it together, you have HCl. Okay, hydrochloric acid, like I said, is normally used for very strong pool cleaners, but it also has a lot of industrial uses as well. The nitric acid is mostly known as nitric acid, but another common name is aqua fortis. We don't actually use this one. We normally just go with nitric acid, and the formula for nitric acid is HNO3. Okay, because it comprises of a hydrogen ion and then also a nitrate. Okay, it's important to know the difference between a nitrate and a nitrite. So let me just quickly write that down. This is a nitrate, and when you have a nitrite polyatomic ion, then it's NO2 minus. So you need to be very sure of your formulas. Okay, and then nitric acid is used for also to produce ammonium nitrate fertilizers. That's maybe the common use, and then also in the chemical industry. Then phosphoric acid is also just known as orthophosphoric acid, but in the lab we just call it normal phosphoric acid, and the formula for that is H3PO4. Okay, because it contains a hydrogen ion, and then it contains a phosphate polyatomic anion. Okay, and well, phosphoric acid we generally use in food flavors and beverages and even cosmetics and skincare products. So they do feature a lot, and even in phosphate enriched fertilizers. Then carbonic acid is basically also known as carbonated water. Okay, like your soda water. And the formula for that is H2CO3. Okay, it contains a hydrogen ion, and then it contains a carbonate. Okay, carbonate ion. So something that might be worthy to remember is that whenever you have a carbonate ion or anion, we can always test for this. Okay, and to test for a carbonate ion in your salt, we can add hydrochloric acid to it, and you will normally then observe fizzing or bubbling or some kind of effervescence, and that is going to be the carbon dioxide that will be released upon adding it to an acid. So what you then can do is you can take the carbon dioxide gas and you can bubble it through lime water. So the lime water is basically calcium hydroxide, and the lime water will then go from colorless to milky. So it's going to change from colorless to milky. Okay, then lastly, we're going to, for the acids, we're just going to look at the ethanoic acid. Ethanoic acid is also known as acetic acid. And basically it is just vinegar, okay, but of course very diluted, so you might have maybe 4% of acetic acid in your vinegar. The formula for this is CH3COOH. Okay, now some of you might have never seen a formula like this, and that's because it's a organic acid. And we will do a few videos on organic chemistry as well, but it is basically a carboxylic acid. So if I can just draw the structure quickly for you, I'm just going to draw it on this side. So if you have a carbon, you can see to that carbon you have 3 hydrogens, then another carbon, then you have an oxygen and an alcohol group. So this entire thing here is a carboxylic acid functional group. Okay, and that is what makes this acidic. Okay, so that's the common acids that we will look at. If we now move to the common bases, one that we always work with, especially in the lab, is sodium hydroxide. The common name for sodium hydroxide is caustic soda, and sodium hydroxide, which is sodium is in group 1 in the periodic table, so it has a charge of +1, and hydroxides are just -1. Then remember that sodium hydroxide, you normally get them in soaps and cleaning detergents. The same as potassium hydroxide, you normally see them in like soaps and so on. Then, so the common name for potassium hydroxide is Li, and the formula is just KOH. Okay, potassium plus a hydroxide. Alright, then we get ammonia. Now, ammonia doesn't really have a common name. We just know it as ammonia. And there's a lot of history to ammonia in chemistry, which is quite fascinating, especially if we get to the chemical industry and we talk about the, let me just write that down here for your info, the Haber-Bosch process, and the history behind that, and manufacturing and chemical equilibrium. So it's really, really fascinating, but we'll get to all of that later on. So the formula for ammonia is NH3. So that's what it looks like. If you go and draw the Lewis structure, okay, you know nitrogen is in group 5 in the periodic table. So it has 1, 2, 3, 4, 5 electrons. Hydrogen is in group 1, so it's only going to pair with that 1 electron, and that is what the Lewis structure will look like. And it has quite a lot of significance in terms of its chemical properties, like its polarity and so on, because of that lone pair. Okay, but we'll discuss that in a different video. Then calcium oxide is also known as quicklime or burnt lime. Okay, and the formula is just calcium oxide. Why? Because calcium is in group 2 in the periodic table. Oxygen is 2 minus, so when they combine, those 2's cancel. Then calcium oxide we normally find in, we normally use them for treating acidic soils, or it could be used in the manufacturing of porcelain or glassware. Then sodium carbonate has a common name that you might recognize, washing soda, and the formula is just sodium carbonate. Remember, sodium is +1, carbonate is 2 minus, so that 2 goes there and that 1 goes there. Don't confuse this with baking soda. Okay, baking soda is sodium hydrogen carbonate. Okay, we normally use sodium hydrogen carbonate in medicines like an antacid, or of course in baking, whereas sodium carbonate is washing soda, so think of washing powder and think of soaps and other detergents. Alright, so just to quickly take us back to my acids, I just want to mention that there's obviously, between these ones, there's very strong acids and there's weaker acids. So these acids would classify as being the stronger acids, which means they ionize more completely, and they will give away more hydrogen ions in solution, and therefore will have a lower pH, whereas carbonic acid and ethanoic acids will rather be your weak. They would be your weak acids. Okay, and these are your strong acids. So weak acids, they ionize incompletely, therefore there's not a lot of hydronium ions in solution, and therefore the pH is not as low. Then for your bases, sodium hydroxide, potassium hydroxide, and ammonia is mostly seen as your strong bases, whereas your calcium oxides, sodium carbonate, and your baking soda would be seen as your weaker bases. So your stronger bases will dissociate much more, therefore they will have a lot of hydroxide ions present, because remember, this is the characteristic of bases, is hydroxide ions, whereas in acids we focus on the hydronium ions. So they will have a lot more of this present and therefore a higher pH, whereas weaker bases dissociate incompletely and therefore you will have a lower pH. Okay, still high but not as high. Alright, so I think that's it for the common acids and bases. Yeah, so stay tuned for the next videos that are coming. If you like this video, please do so. Otherwise, if you want me to do something else or explain something in more detail, please leave a comment.